In this very short video, we are going to understand how um, switch can be a multicast device. With a multicast device, when PC1 wants to communicate with PC3, it will first send a broadcast to the switch, and every device on the switch will receive the broadcast before um, PC1 or the switch is able to resolve the IP address or the MAC address of the destination based on the entry in the MAC address table for PC1 to able to locate the destination. So all that I'm saying is PC1 has a MAC address, PC2 has a MAC address, PC3 has a MAC address. So let me start a capture here, and I'll start one here too. At the moment, the switch is down, so let me turn the switch on. Start. Let me open the console to the switch. And then let's check the MAC address table. At the moment, there's no entries, right? So we are trying to filter for packets. At the moment, you can see STP, Spanning Tree Protocol, packets, and CDP, Cisco Discovery Protocol running. Right, that means we are good to go. Same happening here. So from PC1, I will ping PC3. So let's see what's going on. So the first thing that we did was to ping PC3, and as a multicast device, it will first send a broadcast. So let me search for ARP, and let me search for ARP on PC3. And as we all know, ARP is address resolution protocol. So let's here we are. So here you can see this is a broadcast address, and you can see from here the destination is FFFFF, which means a broadcast address. Same here, a broadcast address, and the source is from PC1. So all that is doing is it's looking for PC3 on the IP address 10.3. So it will first send a broadcast, and it will be received on all interfaces. And then looking at PC2, you can see the broadcast, the packet that is being filtered from PC1 is asking who has 10.3, tell 10.1. So PC1 is looking for 10.3. So another broadcast will be sent for acknowledgement. So who has 10.3 and tell 10.1. That is refused here. PC2 has refused to reply. Even if we search for ICMP pings, we won't see any because PC2 is not on 10.3. It only received the ARP messages because PC1 is trying to resolve the IP address of 10.3 to a MAC address on the local switch. So since PC2 is not on 10.3 and its MAC address is not mapped to 10.3 IP, there is no response from PC2. Now let's check on PC3. This is PC3. First, it receives a broadcast 10.3 tell 10.1. Who has 10.3 tell 10.1. So it sends. So now, as you can see in the second packet sent, 10.3 is at this MAC address. So the MAC address, the IP address on the local switch has been resolved to the MAC address in the MAC table for the switch. So it now has an entry for PC3 rather, on this for the IP address 10.3 on this MAC address. So it has again who has 10.3 and tell PC1 10.3 I'm here at this MAC address. So if we search for ICMP pings, you will notice that PC3 responded to PC1. So the source is PC1, destination is PC3, ICM ping echo request, and then PC3 will respond. 10.3 I'm here, 10.1 is destination echo reply. So this is one way a switch can be a multicast device. And then in our previous video, we saw how a switch can also be a unicast device. So thanks for watching this video. See you in our next video.